Hello everyone, my name is Shyam Manawat and I welcome all of you once again to the series of averages. We are in lecture number 6. In the previous 5 lectures, we have seen the basic formula of average. Let's see what is the formula. So formula, yes, what is the formula? You know the formula, right? That is sum of values or sum of observations by total number of observations. Sum of observations by total number of observations, right? That's the formula we have seen for averages. Now, let me give you a different perspective of average. So, average, which we can also call mean. So, there are three means, and we use them in different situation to calculate the average. So we will see what are these means and what are the situation, in which situation are we going to use them to calculate the average. So first is arithmetic mean. The first one is arithmetic mean. Yeah, okay. Arithmetic mean is the formula which we have used so far, that is this. Then we got harmonic mean, and then we have geometric mean. So let's learn them one by one. Arithmetic mean, which is very famous, the formula average equal to sum of observations, sum of observations or sum of values by number of values, right? That's the main formula of average, and we always use it, or I should say most of the time we use this to calculate the average. In question they will tell you to find the average. We need to see that which formula will get you the right answer, which formula will get you the correct answer. So for that you need to understand in which situation do you use arithmetic mean. So we use arithmetic mean to find the average. We use arithmetic mean to find the average when the unit of the observations is fundamental unit or observations are unitless. Yes. Now, what are fundamental units? Fundamental units are mass, that means weight, gram, kilogram, pounds. Yeah, that is weight, mass, length, distance, height, which is in centimeter, meter, feet, inches. So average height, average length, average distance we calculate. We use what? Arithmetic mean. What is the formula of arithmetic mean? Arithmetic mean equal to sum of values by number of values. The arithmetic mean is what? Sum of values by number of values. Okay, so when we have this kind of unit, length, time, it could be age, it could be the working hours. So you have minutes, hours, days, months, years, they all are what? Time. Temperature, degree centigrade, degree Fahrenheit, and there are a couple of more fundamental units, but these are the units which we see most of the time. So if you look at the previous 5 lectures, you will find that all of them are either having fundamental units or they are unitless. Now what do we understand by unitless? Unitless means it could be marks. What is the average marks of the class in science subject? Remember, marks. So marks has no unit, right? So unitless values. Or number of students. So class A has 60 students, B has 50 students, D has 70 students. Find the average number of students in these classes. Number of students or number of people, that is also unitless, right? So when you have fundamental units or unitless values, that's where you use arithmetic mean to calculate the average. So question will say find the average. So which formula do you have to use there? Arithmetic mean. What is arithmetic mean? Sum of values by number of values. I hope there is no confusion. This is the formula you have used all the time. Another case is you can also see the units You can also see derived units with derived units like the price, okay, or you will say kilometer per hour, which is speed. Okay, so these are called derived units. By the way, what is the difference between fundamental units and derived unit? People who are from science background, you must be having this in your 11th standard. Units, fundamental units, MLT, yeah, and derived units, which are derived from the fundamental units. That means in derived units you will have more than one term, yeah, so you got two terms or more than that, yeah, that is derived unit. Now in the derived unit, if you find the denominator is constant, denominator is denominator is constant, and question said find the average, then you will use what? Arithmetic mean. Let me give you one example. Say you need to find the average speed, okay, you need to find the average speed. The situation is, so let's have one example. Suppose you are traveling from point A to B and you travel this with one halt in between, okay. So you travel from point A, and after 2 hours you realize that there is a puncture in the tire, okay. You're driving and you suddenly realize that there is a puncture in the tire. So next 2 hours you go with the lower speed. Let's say from this point to point P you are using the speed 40 kilometers per hour, and when you travel from P to B you are going with the speed of 20 kilometers per hour, right? Now understand, denominator is constant in this case. If you look at the unit kilometer per hour, yeah, so you can see hour is same for the first duration, yeah, first segment where the speed is different, and for the second segment where the speed is different, right? So denominator is same in both cases. Now if question said find the average speed, then what you do? You will simply apply arithmetic mean formula. Denominator is constant. Did you understand that? Okay, so here average speed will be what? Simple, 40 plus 20 by 2, that is 30 kilometers per hour. That is the average. Straight and simple, right? Yeah, so you must be wondering, if this is what we have, so we are doing this anyways, what is the difference? So what is so different here? So let me show you what is the different thing we are going to address in this part. So this part is clear. I hope this part is clear. Yeah. In case if you get derived unit, you just need to be cautious. If there is no derived unit, if it is simple unit with single term, yeah, mass, length, time, temperature, directly apply sum of observations by number of observations to calculate the average. If the observations are unitless like marks or number of people, apply the average formulas, sum of observation by number of observations. What if it is something else like derived unit where you got two terms? So you need to be a little cautious and see whether denominator of that unit is same with a different observation. Denominator of that unit is same for different observations. So observation number 1, 40 km per hour, 2, 20 kilometers per hour. For this we have 2 hours. For this also we got 2 hours, right? Now let me give you a different perspective of the same. Okay, so I will come back to the same example. I will come back to the example of speed, time, distance after a while. Now second mean is harmonic mean. So what is harmonic mean? Harmonic mean, let me tell you the formula first. So harmonic mean formula, the formula for harmonic mean is number of observations, note it down, number of observations by by what? Sum of a reciprocal. Don't worry, I will explain you what is reciprocal. Sum of reciprocal. Let's take one example. Let's say you have A, B, C as observations, the values, right? And if you need to find out the harmonic mean of that, what will you do? Number of observations. How many observations are there? How many values are there? There are 3 values, right? Divide by sum of its reciprocal. Sum of a reciprocal is what? That means 1 upon. Reciprocal means 1 upon. So 1 upon A, 1 upon B and 1 upon C. Sum of reciprocal, right? This is the formula of harmonic mean. Is that clear? Yes? That's the formula. Note this part. Formula of harmonic mean. Yeah? Now, question is, where do we use it? When and where do we use it? Where do we use the harmonic mean to find the average? So question will tell you, okay, find the average. Now you need to observe that when are you going to use it. So we use harmonic mean. We use harmonic mean to find the average. We use harmonic mean to calculate the average in case of derived units such as price, speed, in which numerator is constant and denominator changes. In which numerator is constant and denominator is changing. Yeah. So let me give you an example of speed. Okay. Let's say you go from home to your college. Okay, let's say home to school. Let's say you're working. You go from home to school. Sorry, home to office. You're working. So home to office and come back to home. While going, your speed is 20 kilometers per hour. And while coming back, it is 30 kilometers per hour. Or let me change this. Say 40 kilometers per hour. Okay. Question said find the average speed. Question said find average speed. Question is find the average speed. Question will not tell you to find the harmonic mean of the speed. It will tell you to find average. Okay. So now you need to decide which formula do we need to apply. So how will you approach such situation? So first you will see whether the unit of speed is fundamental or derived. Do you see that's derived unit? How do you know? Because it's made out of fundamental unit, length and time, right? Kilometer per hour. You got 2 terms there, correct? So average speed here, the average speed here, okay, this is first condition. Now second is you need to see whether numerator is constant or not. Now numerator means what? Now tell me one thing. When going, you cover distance d. While coming back also you cover distance d, right? While going you cover d kilometers, and while coming back also you cover d kilometers. That means with different observations, with 20 kilometer per hour also you cover d kilometers, the distance between A and B, and while coming back with 40 kilometers per hour, still you cover what? D kilometer. So kilometer here with both the observation is same. Yeah. Let's see the previous example. Here with 40 kilometers per hour, you were traveling for 2 hours, and with 20 kilometers per hour, you are traveling for 2 hours, right? You're traveling for 2 hours. Do you see here? Do you see here? The hour, that means denominator is same for both the observations. Whereas here, do you see the numerator, kilometer, is same for both the observation. In that case, if you need to calculate the average, you must use harmonic mean. Then only you will get the correct answer. Right? Okay, is that clear? Are you able to understand the difference? That's only in case of derived unit you need to be little cautious. Right? Okay, for fundamental units or unitless values, straight away apply formula of arithmetic mean to calculate the average. What's the formula of arithmetic mean? What is the formula of arithmetic mean? Sum of observations by number of observations. Okay, so if I need to find out the average speed in this case, we'll say the formula is number of observations. So how many observations are there? 2 divided by sum of their reciprocal. So 1 upon 20 plus 1 upon 40. Simplify this. 2. Simplify this. Yeah, cross multiply. Okay, I will not waste much time in showing you the simplification. We have done such simplification earlier also. Right? It's 2 into 20 into 40 by 20 plus 40. If you simplify this, what will you get? Simplify 1 by 3 here, 80 by 3, which is what? 26.66 kilometer. Do you see this? It's not 30 kilometer. It is not 20 plus 40 by 2. It is not, when you calculate you will get 30, right? It's not 30. It's 26.66 kilometer. That is the average speed in this case. So you understood that where we have to apply harmonic mean. I will give you more example. Don't worry. I have got the next lecture which is on harmonic mean itself. Yeah. So we'll discuss there with different examples. But as of now, did you understand? In question, you will be asked to calculate the average. You need to see the situation and decide which formula to apply. Okay. That is quantitative aptitude, problem solving skills. Okay, so to conclude here, in case of derived unit, such kind of units, if denominator is constant, we will use arithmetic mean to calculate the average. If numerator is constant, then we calculate harmonic mean to calculate the average. Right? Okay, so note this part, difference. This is important. Make a note here. I hope you are using notebook when you are watching my videos. Yeah, make your own handwritten notes. It's very important. Next we have geometric mean. Now geometric mean has got a specific situation, very specific, very particular. The geometric mean, wherever you see average percentage growth, no need of derived unit, fundamental units, no need of that. Simple. If you see average percentage growth, that time you just use geometric mean. Yeah. Now, let me tell you the formula of geometric mean. Geometric mean formula is for observations, for n observation, it will be nth root of product of n values. Note this down. Note this. A1 into A2 into A3 multiply n times. Yeah. Nth root. That means if there are 3 observations, let's say A, B and C. So geometric mean here will be cube root of 3 values, right? So cube root of A into B into C. Okay. And where do we use it? Whenever you find the statement, find the average percentage growth. Yeah. Compounded annual growth. We are going to use it. Okay. Yeah. So one example. Say for a town, the population of a town increases. The population of town is increasing with 20% for first year, 40% for second year, and 80% for third year. That's the increase in the population. Question said find the average percentage increase. Question said what? Find the average percentage increase. Okay, so first of all, you need to see when you have this situation, this has to be solved with geometric mean. So here you should see what is the final value, okay, by initial value, and you calculate the root of nth root. So where n is equal to what? N is equal to number of period. N equal to what? Number of period in this tenure. So in the tenure you can see there are 3 periods: first year, second year, third year, right? Geometric mean. So now to find the final value here, find the final value here, what you do is average percentage growth. What you do is, let's assume the initial population of the town is 1, not x, 1. Even if you take x, you are going to get the same condition, right? Do you remember my percentage lecture? When question is in form of percentage, answer also in form of percentage, we can assume number instead of assuming variable. We get the same answer, right? So if I take the population as 1, yeah, if it is increasing by 20%, so if it increases by 20%, you multiply by what? 1.2. Yeah, 1 plus 20%. You do it what? 1 plus 20% of 1, right? That is what? 1.2. So you multiply by what? 1.2. And then if it increases by 40%, you further multiply by 1.4, because this population is now increasing by 40%. If you are not understanding what I am calculating this percentage part, please go through the percentage series, okay? Please go through that. It's very important. You will understand. Then again it increases by 80%. So you multiply by what? 80% increase, so 1.8, right? This is what you get as the final value, right? Now to apply the geometric mean, what you do? You got nth root. How many terms are there? How many? What is the number of period here? 3. We are talking about 3 period, 3 years, right? So it's 3 cube root of the final, which is 1 into 1.2 into 1.4 into 1.8 divided by initial is 1 anyways, right? So basically there is no need to write this 1, yeah? So it's cube root of simple 1.2 into 1.4 into 1.8. Well, this is going to get you the answer. You will get approximately 1.3904 something, yeah? So this is what you get. That's not the final answer. Hold on, that's not the final answer. Are you okay till now? Yeah, increasing in the population, you need to calculate the average percentage increase. You calculate the final population, divide by initial one, and take the nth root where n is equal to number of periods, right? Okay. Now you see that this expression 1.39, that is nothing but this is average increase. Yeah, this is average increase. If you want to calculate the average percentage increase, okay, this is the average, let's say average here, not increase, average here. If you want to calculate average percentage increase on 1, if it is increasing with 1.39 from 1, divide by 1, multiply by 100, so the average percentage increase come up to 39%. Yeah. So when you solve in the exam, when you get this answer, after decimal what you have is that much of percentage is increasing. Okay. The 2 decimals after the 2 digits after the decimal, by that much percentage is increasing, because when you consider the population to be 1, you are going to find the increase. So increase is what? The value minus 1 divided by 1 into 100, right? 39%. This is average percentage increase. Same thing you can you will see when, if you have come across stocks, shares, mutual funds, there is one important term to compare the stocks, that is CAGR. What is CAGR? CAGR is compounded annual growth rate. What is CAGR? Compounded annual growth rate. Note this term. CAGR is compounded annual growth rate. Okay, that gives you an idea that every year it is increasing by what percent. Yeah, so overall, if you see overall, let's take one example. So there is one share which was initially rupees 100 and it become now say 300. Okay, and that is in 2 years. All right, now question is, find the CAGR, compounded annual growth rate. Okay, growth rate, that will be in percentage form. Yeah, so how do you do that? You will say, sir, this is happening within 2 years, and if I want to calculate for annual, A stands for what? Annual growth rate. Yeah, so if you want to see annual, what is the annual growth rate? In that case, you will say the final value divided by initial, which is 100, and you find the nth root of that, where n is equal to 2. So 2 means what? That is the square root. You never write 2 here in indices. I hope that much you remember school time. Remember, cube root, for that you need to write 3, fourth root you need to write 4, so that so on. But whenever it is a square root, you don't need to write this 2. Yeah, simply draw this sign, simply put this sign of root, so automatically that is square root. Yeah, the way you don't write 1 in the denominator, similarly you never write 2 for the root. That's understood, it is square root. If it is something else, let's say 3, 4, 5, then we have to write. Okay, so CAGR, compound annual growth rate, in 2 years, if 100 rupees share become 300, what is CAGR? Square root of, because it's 2 years, that's why square root. Had this been 3, we would have said 3 cube root. Okay, final divided by initial and then root. This is nothing but what? Square root of 3. Square root of 3 is how much? 1.732. Remember, square root of root 3 is what? 1.732. Some numbers you have to by heart. This is one of them. Note this down. Note this. Square root of 3 is 1.732. Note this. Done? So this is the square root, or this is the geometric mean we have got. Okay, so to say compounded annual growth rate, I need this value. This value is always in percentage. So what will you say? You will say, okay, this is the increase, or this is increased value is what? 1.732. okay, from 1. Okay, so you always minus from 1, divide by 1 into 100. Okay, after getting this mean, this is what you do. Whenever you get the geometric mean in such case, always do this. Minus 1 divided by 1 into 100. So what you get here? You get 73.2%. Yeah, I hope there is no problem here. For geometric mean, for average percentage growth, for compounded annual growth rate, once you calculate the geometric mean, you get some 1 point something. You always get 1 point something. You will always get. So always, whether it is 1 or 2, that's a different matter. But always, whenever you need to find the growth rate, you will, after finding the geometric mean, you will do minus 1 divided by 1 into 100. Minus 1 divided by 1 into 100. This is what you need to do always. Okay, same thing here. You got 1.732 minus 1 divided by 1 into 100. Okay, there is no significance of divide by 1, but still minus 1 divided by 1 into 100. Okay, so what value you get here, that is the annual growth rate, that is compounded annual growth rate. Yeah, so remember these terms, CAGR or growth percentage, average goes percentage, average percentage increase. This is what you do. Yes. Okay. Now last point here. What is the relation between arithmetic mean, geometric mean and harmonic mean? What is the relationship between arithmetic mean, geometric mean and harmonic mean? So here we say arithmetic mean is greater than equal to geometric mean is greater than equal to harmonic mean. Note this point also. It's very important, very important. We will be using it in future. So note this. The relationship is arithmetic mean greater than geometric mean greater than equal to harmonic mean. Geometric mean square is equal to arithmetic mean into harmonic mean. Yeah. Greater than equal to. So what do we mean? It could be greater also. It could be greater or equal. Yeah, it could be greater or equal. Greater or equal. Now, in which case? Greater if observations are different. 20, 30, 40. Equal when observations are also equal. 10, 10, 10 or 20, 20, 20. Alright? Yeah, I hope you understood this. And this is one of the relations. So these two relations you should note, remember. We have seen this different prospect of average, that is arithmetic mean, geometric mean, harmonic mean, which we use to calculate the average in different situations. So you should be aware about in which situation for average you use what formula. Most of the time you are going to use the arithmetic mean, that is sum of values by number of values, right? So this is it in today's video. My name is Shyam Manawat signing off. I will see you in the next lecture. Till then, stay happy, stay healthy. Bye bye.